Ladies and gentlemen, let's begin today. Video we're going to be going through a recent interview I conducted with AMD's Head of Global Technical Marketing, Robert Hallock. Now, this interview we're going to be going through multiple different subject matters, including, but not limited to, virtual reality, Polaris, asynchronous compute, DirectX12, Vulkan, and a whole bunch of other stuff. Besides, unfortunately, Robert could not provide me audio commentary in regards to the questions. He didn't have time, so I'm going to have to read out his responses on his behalf. But with all of that said, I'll say one more thing, and that is you can find the written version of this interview in the video's description. But let's get on with it, shall we? So I asked, were AMD happy with the live crowd and internet's reaction during Capsation, which of course was held during GDC. I was asking this particularly in regards to both virtual reality and the sneak peek of Polaris. Robert says, and I quote, "Feedback seemed pretty positive. I don't think people were really expecting us to show off a second desktop GPU based on the Polaris architecture. So the surprise was nice, and the chatter afterwards has been very pleasing." Next question. It was reported during Capsation that Polaris 11 GPU was running 4K VR video content passively, that is, without an actively running fan. Can you provide some more insight in how this is achieved and potential uses? Robert responds, all of this comes down to performance per watt or power efficiency. The more performance you can produce for every watt of power consumed, the easier it is to explore wild uses, cases like fanless VR. We've achieved a 2 times performance per watt improvement with Polaris, so there's still headroom to explore this stuff. For everyday users, that kind of power efficiency will manifest as cool and quiet operation load. Now, the next question. The Hitman demo was rather interesting, albeit pretty short. Can you confirm Hitman was played at max settings, DirectX12 1440p at prototype hardware, and at 60 FPS? Robert responded that I was correct, that it's the first public showcase of Polaris 10 running DirectX 12 at 1440p, Hitman of course, but he couldn't confirm any more details at the moment. Next question. Speaking of Polaris, can you elaborate to the new naming conventions of the Radeon graphics cards? He responds, they will still be called Radeon. Polaris 10 and 11 are our code names for the physical graphics chips themselves. These are in isolation of anything that is attached to the PCB. Continuing the Polaris theme, the GPUs shown so far are, in comparison to many traditional graphics cards, pretty small. Are smaller board designs something AMD are going to prioritise in the future, particularly because of technologies such as GDDR5X and HBM? Robert responds, much of the GPU's PCB size is dictated by power circuitry and routes that link it all together. If you have a more efficient GPU die, then you don't need quite as much power circuitry and the board size can be reduced. That's been historically true for a long time and will be no different with Polaris. I next asked a slightly more technical question. I'm trying to get a bit of a mix here from more common sense questions all the way down to the more technical. What are the primary benefits of switching over to 14nm FinFET? We've heard a lot made of the huge performance gains PPW over 28 technology, but what are some of the other benefits? Robert Hallock responds, a big benefit is the power efficiency and manufacturability. On every point along the clock speed versus power curve, FinFET is noticeably better than 28nm. And since FinFET gates are smaller than 28nm planar gates, you can simply produce more chips per wafer. On to DirectX 12. Now it's fun here for users of playable games. How do AMD feel about the API's adoption rate and performance? Robert responds, the DirectX 12 adoption rate is on track to be the fastest ever. We know that this is true based on our discussions with software partners, comparing it to what they've already been telling us historical records are for DirectX 9 and DirectX 11. And performance for AMD products has been exceptional. Hitman, Ash of the Singularity, Quantum Break, all of those DirectX 12 games have produced runaway wins for Radeon GPUs, and asynchronous compute only, quote, widens the gap. Question is, my understanding that Vulkan was pushed forward with a lot of the backbone of AMD's Mantle API. Are you happy with the progress of Mantle and open source nature of the API, and do you hope it will evolve over the next 12 or so months? You're right, says Robert. We donated the API specification from Mantle to the Kronos Group. Editors note Kronos Group are the folks responsible for the administration of Vulkan, back to the quote, to jumpstart the process of bringing Vulkan to life. Being iterated on the industry standard represents one of the victory scenarios we envisaged for Mantle at birth, and we're thrilled that it's happened. Now we're just looking forward to working with ISVs on expanding the library of games based upon Vulkan. We've already done some good work with the team behind the Talos principle too. I then asked, well, the logical question for that is, will AMD's Mantle API continue to live on, for example, with tools such as Liquid VR? Is this correct? Robert responds, that is correct. Mantle is born as a flexible API to solve, quote, challenges in graphics. When Mantle was conceived, the big challenge was draw calls. Editor's note, my note, if you will. Do you remember that? Like back in 2013/14, how many, actually I think it's more 2012 to 2014 to be fair, there were so many bloody questions on draw calls. Anyway, getting back to Robert's quote. How do we get more than 7,000 draw calls on a scene? Of course, Mantle could do over 100,000 draw calls, and every major graphics API has now been able to be reconfigured to follow the path that Mantle blazed. The draw call isn't a big challenge anymore. Now VR is the next big challenge in graphics. Smoothness, immersiveness, latency and presence. Mantle is great at those things. Adapting Mantle in many ways to underpin Liquid VR was an obvious but critical step forward. Next question. AMD's GPUOpen is a pretty brave decision for placing the code in the public domain and allowing developers to tweak, modify, download and use it how they need. Why did AMD choose to do this? Robert responds, everyone wins when the full source code to a game is known. Developers win because it's easy and straightforward to solve a bug, implement a call or optimize performance with architecture. Gamers win because they can get a fast, stable, good looking game, and we win because we learn a little bit more how developers think and what they need when the code is transparent and discussable. I think we can all agree this is a win/win/win, and that's why we challenge the industry with GPUOpen. So I guess from there we need to move on to virtual reality, right? Seems like a logical move. I asked, are AMD happy with the adoption rate and support of virtual reality is receiving? Do you believe that the next year or two are almost going to be testing phases as developers experiment with the hardware and usage, and as hardware itself improves, such as higher resolution headsets and costs are reduced? Robert responds, let's be clear, the testing phase has already happened. We're now in the first generation of customer headsets, and the appetite is already sensational. Everywhere you go, to gamers, to developers, to hardware companies, to content creators, everyone is over the moon about getting into the VR game. The genie isn't going back into the bottle. Now our goal is to show that people Radeon hardware is more than capable, today and tomorrow, of delivering what's needed for unblemished presence on the Vive and the Rift. We understand that we are just one of two vendors in the hardware portfolio to power these headsets, and we consider that a supreme responsibility, and that's not lost to us. But Rajaz Kadori's vision for the hardware and software demonstrates total awareness of the problem, the solution and the path. It's inspiring, and it's already clear to me that we're on the right track when I put on a headset and have a frustration-free experience with a large chunk of our GPU portfolio. What's also true about VR is we all win when the ecosystem gets bigger. So we want to make it very easy for less hardware-aware gamers to get in on the fun too. That's why we unveiled the VR Premium brand at the Capsaicin event. It's an at-a-glance way to say, yep, this hardware definitely meets the requirements for virtual reality gaming, end quote. Moving on to HDR question now. So during the GDC presentation from Microsoft, which was entitled DirectX 12 Advancements, they reiterated their support for HDR and claimed that adoption rates for displays would likely be faster than even 4K. So then I asked AMD on their take on this. Robert responds, I'm a display snob, so HDR is one of those technologies I just can't get enough of. Better contrast, blacker blacks, whiter whites, sharper picture, more nuanced, more colours, more vivid colours, more accurate colours. HDR is a huge and obvious improvement in every conceivable way to measure the performance of a display. It's a technology that makes you say, whoa, when you see it for the first time, and that's really hard to go back to your SDR TV or monitor you have at home. If you've ever participated in a TN versus IPS debate, HDR is right up your alley. Those picture quality benefits extend to any sort of content where HDR is aware, where you can include movies, photos, games. Just imagine a nighttime scene with details and nuance as daytime scenes. Imagine seeing shades of red, gold and cyan you've never been able to see before. Imagine moonlight or starlight that's crisp and pure, doesn't turn to dark night sky a weird shade of grey. That's all possible with HDR, and GPUs based on the Polaris architecture will support it. We also plan to support the HDR on Fury, Nano and the R9 300 series too. HDR has little to no impact on the overall performance of the game because games already render in HDR color spaces inside the game engine. Then, a process called tone mapping compresses and remaps the colours in finished frames so they'll be shown on your standard SDR TV or monitor without appearing perceptually inaccurate. We're working with game developers to establish more intelligent tone mappers that can identify the capabilities of HDR display and tone map the content on a HDR profile that perfectly matches what the display can do. As with any other monitor, the better your display is, the better the process will look, but in my opinion, any HDR display looks much better than even the best SDR display. Next question, and this one regards Freesync and whether AMD are happy with its adoption rate, where they see the technology moving in the next year or so. Freesync is an excellent position in the market, says Robert. In 13 months, the technology has grown from 3 supporting monitors to over 50 supporting monitors. We got LCD overdrive working within 30 days of launch, and we have multiple partners that reach down to 30 Hz to cover all for the full range of playable frame rates. We have a low frame rate compensation, which of nearly 20 Freesync monitors can sustain a smooth gameplay down to around 25 frames per second. There are 4K Freesync monitors, ultra-wide Freesync monitors, 1440p Freesync monitors, 1080p Freesync monitors, and many reviewers have noted that the average Freesync display costs a lot less than an average G-Sync display. That looks like a total victory to me. Somewhat off topic, or rather somewhat out of Robert's quote, I have to say that my first experience with either a Freesync or G-Sync monitor has been really positive, and my own review of the AOC G, what model number was it? AOC G2460PF, that was it. Was absolutely excellent. I absolutely love the monitor. It makes an absolute massive difference with Freesync, I must confess. I'm really impressed with the technology. When you're playing games such as like Twitch-based titles, even games like Counter-Strike, or to be honest, even RTS games, you can definitely notice the difference. I have to say that Tomb Raider 2016, I guess you could say, on the PC looks absolutely breathtaking. What technology and games are you personally looking forward to over the next 12 months? These are his own personal opinions, of course. Robert responds, I really want a Polaris 10 based GPU, a HDR FreeSync monitor, a copy of DXX and Mankind Divided, and I also imagine I'll get sucked back into World of Warcraft when Legion arrives. Question 16. During the interview, we've spoken a lot about power efficiency, GPUOpen, virtual reality. With this in mind, can you provide insights into AMD's goals regarding future graphics technology? Where do you predict the market will be going? We believe that graphics is now entering the era of deep and immersive pixel. It's not enough now to simply drive huge whack of pixels at playable frame rates. Those are table stakes. It's still a mission to go faster, of course, but the industry started to weigh in more heavily on the value of packing more information into the pixels. Those pixels have to be more colourful and interesting than they've ever been. That's where technology like HDR and VR come in. From there, the trajectory is incredible. We want to hit 16K by 16K pixels per eye. I just want to reiterate that. We want to hit 16K by 16K pixels per eye at 240 FPS. That's enough pixels and responsiveness to exceed retina acuity. We want HDR panels with incredible dynamic range that the human eye cannot distinguish between the panel and looking at the same scene out of a window. That is all achievable in our lifetimes. I then asked, backtracking to the Capsation event, Mr. Kadori spoke about the future he'd like about an immersive era, and Robert had already mostly answered that in question 16. I then asked, I understand AMD are pursuing the true audio technology. I've not really heard the technology is being used primarily in games consoles. Can you confirm this is the case, or will you be pushing true audio for the PC? He said, and I quote, "We demonstrated true audio technology at Polaris and Capsation. We believe that virtual reality especially benefits from rich nuance and positional soundscapes." Last time we spoke, you helped explain what asynchronous compute was and how DirectX 12 has dropped. Now we can start seeing the benefits of the technology. Can you explain a little as to why AMD decided to include asynchronous compute engines in GCN hardware, and as you pleased with its adoption rates with developers? Robert responds, "We predicted the GPU compute world would be popular to PC gaming in 2009 or 2010. Engineers recognized that the setup for effects like lighting, shadowing, reflections, physics, and AI, DOF, depth of field, could be extracted from the graphics cube and parallelized. It was a route to free performance. That guided our hand to bet on asynchronous compute engines in GCN, graphics core next. Next, we ensured the hardware was accessible to the consoles to prime the pump in game developer land. Then we brought Mantle to life on the PC to train PC gamer developers on how to access asynchronous compute engines and to use asynchronous compute engines for PC gaming. Then came DirectX 12, and then we had donated Mantle to the Vulkan project, and now here we are. Radeon is offering incredible performance in DirectX 12 applications, and we're excited to do the same for Vulkan as the API grows. Our 5-year plan has begun to bear fruit for our customers, and the wins just keep coming." I then ask, with both the PlayStation 4 and the Xbox One being developed on for some time, and AMD believes their existence has benefited PC, and indeed AMD, aside from financially, it's my understanding that asynchronous compute has been used in both Xbox One and PS4 for multiple titles. Robert responded, "You nailed it. As we move into DirectX 12 and Vulkan era, you're starting to see how GCN's presence in the consoles has cultivated intimate familiarity with ISAs amongst games developers. Every developer cut their teeth on things like asynchronous compute in the console space, and they're now porting that knowledge onto the PC space to improve PC gaming experience. By the way, just for your FYI, developers who are already using asynchronous compute on the PlayStation 4 alone are games like Battlefield 4, Infamous Second Son, Children of Tomorrow, and many others besides. This was back in 2015 though, so there's probably a lot more titles after that, and we've already heard of a couple. We've done some analysis on some others anyway. So how much more work is it on the part of developers to take advantage of asynchronous shaders for meaningful performance gains? Robert responds, we've had reports of developers getting the feature up and running in just a weekend. Naturally, more extensive concurrency is encouraged by forward-thinking and modern engines that can dispatch a lot of multi-engine work, for example, the Nitrous engine, but presuming the infrastructure is in place, it's not overtly challenging, and lots of new engines and engine rewrites are coming online for the new graphics APIs. I then asked a question regarding virtual reality and latency. So of course, one of the big problems with virtual reality is latency. Essentially, it can cause everything from nausea down to just lack of immersiveness. So I simply asked how are AMD trying to solve this problem, which is really down to Liquid VR, and what can we expect for AMD in that regard. Robert responds that he believes the best option for you would be to watch free AMD videos, so I'm going to link them in the video description as well, but they're also clickable in the article if you prefer. Anyway, with all of that said, hopefully you've enjoyed the video. It's been a pretty lengthy one actually for me to record, and kind of pretty damn interesting. Thanks a lot to Robert once again for answering all of the questions. Do remember to subscribe if you want more videos on this topic, and if you can share and like and do all that stuff, that would be absolutely fantastic. Once again, as I said, the full article is linked in the video description, so go ahead and give it a read. There are a couple of interview questions I didn't respond to, I didn't include in this particular video, mostly because of time-orientated reasons. But hopefully you've enjoyed the video. I'll see you soon. Take care. Bye for now.